Yeah, cut through the noise.
Right. And today we're going to be diving into this critique of something called substantial motion.
Yeah.
It's a concept in Islamic philosophy that's, it sparks some pretty heated debate.
Quite a bit, yeah.
We're specifically looking at a physicist named Dr. Majid Bourmand.
Okay.
And his analysis of Dr. Abdulkarim Soroush's book, The Restless Nature of the Cosmos.
Right.
It's called Nahad in ارام Jahan in Persian. So I guess you could say we're going to be looking at a kind of a clash between philosophy and modern science.
Yeah, that's a good way to put it. I mean, the sources you said, they really do highlight some pretty fundamental tensions between a long-standing philosophical framework and how we currently understand the universe through the lens of science.
Right.
So I think our main goal today is to, really get to the heart of the arguments about this whole substantial motion thing.
Yeah.
Lay out the challenges that Dr. Bourmand is presenting.
Okay, so it seems like Dr. Soroush's book, he was trying to kind of like popularize the ideas of this guy, Sadra, and present his philosophy of substantial motion as something really original, something really important. Mm-hmm. He even compared it to like, Newton's law of gravitation and Einstein's theory of relativity, like huge groundbreaking scientific theories.
The implication being that this is on that level.
Yeah.
Which is a fascinating claim right from the outset.
Yeah.
Like Dr. Soroush seems to believe that this idea of substantial motion is not just like a novel concept within a specific philosophical tradition, but like something that can reshape our whole understanding of like reality itself.
Yeah.
The relationship between like mind and body.
Wow.
All these really big questions. And that's really where Dr. Bourmand comes in, right? Mm-hmm. He's coming at it from a very different perspective. Okay. He's a physicist.
Right.
So he's looking at these claims and he's like, wait a minute, I think there's some serious errors here. And I think there's some misunderstandings about how modern science actually works.
Yeah.
He even says he's kind of surprised that these ideas have gone on for so long without someone really putting them under the microscope.
Really?
Yeah.
Okay, so to really wrap our heads around this whole thing, we've got to go back in time a bit, set the scene, give us some historical context. So where did this whole substantial motion idea come from in the first place?
Okay, so we need to transport ourselves back to the time of Sadra.
Okay.
He lived from 1571 to 1640.
Okay.
And this is where it gets really interesting.
Okay.
He was actually a contemporary of Galileo.
Galileo,
the guy who...
Yeah.
Galileo lived from 1564 to 1642.
Okay.
So they were living at the same time.
Same time. Okay.
But here's the kicker. Galileo, he's out there promoting the heliocentric theory.
Okay.
Right? That the Earth revolves around the sun.
Revolutionary stuff.
Totally revolutionary for the time.
Yeah.
But Sadra and his followers, they were sticking with the older model.
Really?
Yeah, the Aristotelian and Ptolemaic view of the universe.
Okay, so they thought that everything revolved around the Earth.
Exactly, an Earth-centered universe.
Yeah.
So right from the start, you've got a really fundamental difference in their worldviews.
That's a pretty stark contrast.
Oh, yeah.
Even for back then.
Yeah, and it's not like this changed overnight.
Right.
I mean, you've got Mullah Hadi Sabzafari.
Okay.
He was a follower of Sadra.
Okay.
He lived much later, from 1797 to 1878.
Okay.
And he was still working within that Ptolemaic framework.
Wow.
Centuries after Galileo.
Really?
Yeah. Centuries after Isaac Newton.
Wow.
Newton, remember, lived from 1643 to 1727.
Yeah.
He's the one who completely transformed our understanding of motion.
Yeah.
With his laws.
Right.
Basically overturning Aristotle's physics.
Right.
So while Europe was going through this huge scientific revolution, this particular intellectual tradition in the Islamic world was on a very different trajectory.
Yeah.
And it's crucial for us to remember just how much scientific progress has happened since the 16th century.
Oh, yeah.
I mean, think about it.
Yeah.
Atoms, right? We discovered atoms.
Yeah.
We figured out their internal structure.
Yeah.
How they behave.
Yeah.
We figured out what stars are made of.
Yeah.
DNA, the Big Bang Theory, thermodynamics,
right,
relativity, quantum mechanics, all these massive discoveries.
Yeah.
They were completely unknown to Sadra and his contemporaries.
Yeah. So this is like a huge amount of knowledge.
It's huge.
That's come about since then.
It's massive.
But even with all that, this idea of substantial motion has continued to be a big topic.
It has.
Within Persian Islamic thought.
Yeah.
So this is the setting. This is the backdrop for Dr. Borman's critique.
This is it.
Okay. Now, for the sake of our listeners, we have to ask, what exactly is substantial motion?
Right.
How did Sadra define this thing?
Okay, so the way Dr. Soroush interprets Sadra, he says that motion is basically this gradual transition.
Okay.
It's a transition from what they call potency to actuality.
Okay.
Potency is like a state of imperfection or potential.
Okay.
And actuality is a state of perfection or realization.
Okay.
And they use this example.
Yeah.
They talk about ripening apple.
Okay. Yeah.
So the unripe apple has the potential to become ripe.
Right.
And as it gradually ripens, it's considered to be moving towards its full actuality. You know, its perfection.
Okay, that makes sense. So the apple example helps. But how is this different from, like, how Aristotle thought about motion?
Right.
Because his ideas were pretty influential back then, right?
Hugely.
Yeah.
So Aristotle, he kind of categorized motion into four main types.
Okay.
First, you've got locational motion. That's just moving from one place to another.
Okay, simple.
Pretty simple, yeah. Then you've got motion of orientation.
Okay.
Like something spinning.
Okay.
Then there's qualitative motion.
Okay.
So that's like changes in properties like color.
Right.
And finally, quantitative motion.
Okay.
That's like changes in size or amount.
Okay, got it.
The key point in all of these Aristotelian categories is that the substance of the thing, what it fundamentally is, that stays the same.
Right.
It doesn't change.
Okay.
So the apple is still an apple.
Right.
Even if its color changes.
Yeah.
Even as it ripens.
Yeah.
It doesn't lose its core identity.
Got it. So the fundamental nature of the thing doesn't change.
It doesn't change, yeah. And that's where Sadra's big idea comes in.
Okay.
What Dr. Soroush calls his profound discovery.
Okay.
He's saying there's motion in the substance itself.
Whoa. Okay.
So the very essence of a thing is not fixed.
Okay.
It's in a constant state of change.
That's a big idea.
It's a big idea.
Yeah.
So it's like not just the apple ripening.
Yeah.
It's the apple itself in its very being that's changing.
Wow. Okay. So what was Sadra's reasoning for this?
Right.
Like, why did he propose this motion in substance?
Okay. So the first argument, the way Dr. Soroush presents it, it goes like this.
Yeah.
If the accidents of a thing, the attributes, the properties, if those can change, and the substance is the underlying cause of those changes, shouldn't the substance itself also be able to change?
Okay.
Why would change be limited to just the attributes?
Right. I guess it's like, shouldn't the cause also be subject to the effect?
Yeah, that's a good way to think about it. Like, why would one be fixed and the other not?
Right. Okay. But then didn't other philosophers before Sadra reject this whole motion and substance thing?
They did, yeah.
Like, what was their issue with it?
So philosophers like Ibn Sina, Avicenna, they raised this really important point about identity.
Identity, okay.
They said for us to say something has changed, there has to be something stable about it.
Yeah.
Something that persists through the change.
Yeah.
Otherwise, what's changing?
Right.
If everything about it is different, how can we say it's the same thing that's changed?
Right.
So they were worried that motion in substance would just dissolve the very idea of a stable, identifiable entity.
It would make things pretty slippery.
Very slippery. So how do we reconcile this with how modern science approaches this question of change?
Right, because modern science obviously has a lot to say about change.
It does.
So how does it handle this?
So from a scientific perspective, all the big changes we see, the macroscopic changes, right?
Yeah.
Like an apple ripening, something changing color or growing.
Yeah.
It's all down to the motion, the combination, and the separation of atoms and their parts, like electrons.
Right.
And if you look at the level of individual atoms, especially the stable ones, like hydrogen, you know, the hydrogen that formed way back in the Big Bang.
Yeah.
They don't really undergo this kind of deep philosophical substantial transformation that Sadra was talking about.
Right. Okay.
A hydrogen atom stays a hydrogen atom.
Right.
It doesn't become something fundamentally different.
Okay. But Dr. Soroush does talk about this.
He does, yeah.
He makes this distinction between philosophical atomism and scientific atomic theory.
Mm-hmm.
What's he getting at there?
So his point is that because atoms, in the scientific sense, they're not indivisible. They have protons, neutrons, electrons inside them.
Yeah.
They're not like these unchanging particles that some ancient philosophers thought they were.
Okay.
So he's saying that scientific atoms can't be the ultimate unchanging source of all change.
Okay.
And that we need this idea of motion in substance
as
the more fundamental explanation.
Okay, I see. But Dr. Borman, he doesn't buy this, right?
No, he doesn't.
He sees it as a misunderstanding of modern physics.
Yeah.
So what's his take?
He's saying that even though atoms aren't indivisible in the way those early philosophers thought, they're still the fundamental building blocks of everything.
Right.
And they're the primary agents of change in the universe.
Okay.
Through their interactions, their rearrangements.
Okay.
And importantly, modern physics doesn't really look for an ultimate cause for the motion of these particles in the way that Aristotle was looking for an ultimate cause.
Okay.
It describes their behavior through things like the energy from the Big Bang.
Okay.
And the Heisenberg uncertainty principle.
Okay.
Which says there's an inherent level of indeterminacy at the smallest scales.
Okay.
This leads to stuff like vacuum energy.
Vacuum energy? What's that?
It's the energy of empty space itself.
Wow.
Which is a pretty wild concept when you think about it.
Yeah, that's definitely different from what they were talking about back then.
Oh, yeah. It's radically different. And Dr. Borman even quotes Wolfgang Pauli.
Okay.
You know, the famous physicist.
Yeah.
He said, and I quote, "This stuff is not even wrong."
Ouch!
When he was confronted with a bad scientific theory.
Right.
And that really illustrates this disconnect between substantial motion and how we understand physics today.
It sounds like a pretty harsh assessment.
It is.
All right, let's move on to another aspect of this debate.
Okay.
Heat.
Heat, yeah.
How does substantial motion try to explain what happens when something gets hot?
Okay, so Dr. Soroush gives us 3 possible explanations.
Okay.
First, he rejects the idea that there is a distinct quality called heat that gets transferred from a hotter object to a colder one.
Okay.
Or that there are specific heat-carrying particles that move between them.
Okay.
And then he suggests what he thinks is the most acceptable explanation, both philosophically and, in his view, scientifically.
Okay.
Which is that the object is just placed in a set of conditions that allows its inherent capacity for heat to be actualized.
Okay.
And that causes it to get hot.
Okay, so that sounds a little abstract.
It is.
How does modern physics actually explain heating something up?
Right, so let's use a simple example, like a microwave oven.
Okay.
Dr. Borman talks about this.
Okay.
So microwaves are a form of electromagnetic radiation.
Yeah.
And when you put food with water molecules into the microwave, these waves cause the water molecules to vibrate.
Okay.
Much more rapidly.
Okay.
And this increased kinetic energy at the molecular level is what we perceive as an increase in temperature.
Okay.
It's how the food gets hot.
Got it.
And you don't need this separate transferable heat quality or anything like that.
Right.
It's all about motion and energy transfer at a microscopic level.
Okay, so modern physics has a very clear explanation.
Yeah.
That doesn't rely on these Aristotelian ideas of substance and accident.
Exactly.
Yeah.
And Dr. Borman points out that modern physics has revealed a universe that's way more dynamic and energetic than Aristotle could have imagined. I mean, even the vacuum of space, which Aristotle thought of as just emptiness, is now understood as this crazy place full of virtual particles and energy fluctuations.
Really?
Yeah. It's wild.
Yeah.
So the idea that motion in substance is some kind of radical departure from a static view of reality doesn't seem so radical anymore.
Yeah, I see what you mean. All right, let's dive into another principle.
Okay.
Sadra said that the transfer of accidents is impossible.
Yeah.
What's the logic behind that?
So Sadra argued that accidents, things like color or shape or temperature,
Right.
they don't exist on their own.
Okay.
They have to be the color, shape, or temperature of something.
Right.
So he reasoned that you can't transfer an accident from one object to another.
Okay.
Because that would mean it could exist by itself for a moment.
Right.
Detached from any substance.
Okay, I see.
And Dr. Borman uses this great anecdote to illustrate this.
Really?
Yeah. He talks about Hakim Sabsavari.
Okay.
He was a major follower of Sadra, lived in the 19th century.
Oh.
And apparently, Sabsavari refused to be photographed.
Why?
Because he believed, based on this principle, that the camera would somehow capture and transfer his image.
Wow.
His visual appearance.
Oh.
Which, according to their philosophy, should be impossible.
That's pretty wild.
It is. And it shows this disconnect between the abstract principle and how the world actually works.
Yeah, it's a good example. So what's Dr. Borman's point here?
He's basically saying that you can start with definitions that seem really clear.
Yeah.
But if those definitions don't match reality, then all your logical arguments built on them are going to be wrong.
Yeah, it's like building a house on a shaky foundation.
Exactly. And he brings in A.J. Ayer, the philosopher, who said that a lot of philosophical propositions are about the meaning of words, not about facts about the world.
Right. Okay, let's talk about time.
Okay.
Dr. Soroush compares substantial motion to Einstein's theory of relativity, right?
He does, yeah.
What's the connection there?
So, Sadra said that the order of events in time isn't determined by some external clock.
Right.
Like Newton thought.
Right.
It's inherent to the events themselves.
Okay.
And Dr. Soroush thinks this is in line with relativity.
Okay. But doesn't Einstein's theory actually contradict Sadra's idea?
It does, yeah. The key thing about special relativity,
yeah,
it's that things like simultaneity, whether two events happen at the same time,
right,
and the order of events, it's not absolute.
Okay.
It's relative to the observer.
Right.
So unless events are causally connected,
yeah,
which means a signal could travel between them at or below the speed of light,
yeah,
different observers will disagree on which event happened first.
Right.
So this goes against Sadra's idea of an absolute time order.
Okay, so the very theory Dr. Soroush uses to support his argument ends up contradicting it.
It does, which suggests maybe he didn't fully grasp the physics.
Yeah, that's a pretty big irony. Okay, finally, let's talk about the very basis of substantial motion, the concept of substance itself.
Right.
What does modern science say about this?
This is where philosophy and science really part ways.
Okay.
Bertrand Russell, the philosopher,
yeah,
he called substance a metaphysical mistake.
Whoa, okay.
He said it comes from how we use language.
Okay.
We talk about things having properties.
Right.
So we assume there's some underlying substance that has them.
Okay.
But Sadra, he thought that the difference between things,
yeah,
like a horse and a cow,
yeah,
it's in their substantial form or nature.
right.
Like
right.
there's some essence that makes them what they are.
Okay.
But science doesn't really buy into this idea of fixed substantial forms.
Right.
It says that the properties of things come from their atoms and molecules.
Okay.
And how they're arranged.
Okay.
Dr. Borman gives these cool examples to show this.
Oh, yeah.
He talks about Daniel Robinson's thought experiment with a hamburger.
Okay.
You eat a hamburger, it was once part of a cow.
Yeah.
The cowness goes away.
Right.
It becomes you. How does that happen if there's some fixed substantial form of a cow?
Right. Good point.
And then he talks about a clock.
Okay.
Is there some essential clockness beyond the parts and how they work together?
Yeah, I see what he's getting at.
Science says no.
Right.
Things are just particular arrangements of matter and energy.
Okay. And what about that ribosome example?
Right.
That's a good one, too.
The ribosome in our cells.
Yeah.
It's like a tiny machine.
Right.
It takes matter, like from that hamburger,
yeah,
and rearranges the atoms.
Yeah.
Based on instructions from our DNA.
Right.
And that's how it becomes you.
Wow. Okay.
So this shows how dynamic living things are.
Yeah.
It goes against the idea of fixed substantial forms.
Right. And Dr. Borman's point is that this whole idea of substantial form, which science has kind of rejected since Descartes,
Mm-hmm.
it's the very foundation of Sadra's theory of substantial motion.
It is.
So it's like the whole thing is built on shaky ground.
Exactly. So the main critique here is that substantial motion is rooted in an outdated view of substance in motion.
Yeah.
One that doesn't fit with modern science.
Right.
And Dr. Borman asks some pretty challenging questions to philosophers working in this tradition.
Like what?
He says, why are we still relying on these pre-scientific ideas when they contradict so much of what we know about the world now?
Right.
And what's the point of promoting these ideas when they seem to be based on misunderstandings?
Yeah, that's a good question. I mean, it highlights the importance of being open to new evidence.
It does.
Even if it means changing our minds about things we've believed for a long time.
Exactly.
And if this concept of substantial motion is flawed, then all the philosophical conclusions drawn from it,
right,
about God, the cosmos, mind, body, all that, they're called into question too.
Yeah.
We might need completely new ways of thinking about these big questions.
We might.
So that's something for all of you out there to ponder.